All right, so we're going to pick right back up with dividing polynomials, and today we're going to review synthetic division. Um, you might you might remember synthetic division. There's some special rules that go along with it. When you're using synthetic division, your divisor must be in the form of x minus c. So like this says x minus 3. If it said 2x plus 5, that's no good because this 2 out in front is going to make synthetic division not work for us. So you'd have to do regular long division. So real quick, let's look at how we do it. Hopefully you remember. When your factor is x minus 3, you take whatever the x would equal. So in this case, it'd be the opposite of negative 3. So it'd be just 3. You put it in a little box like this, and you write out these coefficients. And again, if there's any zeros, you have to account for them. So we're going to write 4, 3, negative 1, and 8. And we're going to draw a line like this. And for synthetic division, we are going to bring down this 4 and write it underneath here. And then we're just going to take this number, multiply it by whatever's here, and write it here. So 3 times 4 is 12. Now we add this straight down. 3 plus 12, 15. Same thing again now. Multiply. 3 times 15, 45. Add straight down. Negative 1 plus 45, 44. Multiply again. 3 times 44 is 132. Add straight down, 140. Now, our original polynomial was a degree 3. So it had a x cubed, x squared, an x, and a non-variable term, a constant. So our new is going to be 1 degree less because we divided it by something that was 1 degree. So now instead of being a degree 3, we're going to have a degree 2. So this is going to be 4x squared plus 15x plus 44. Okay, our remainder is this piece, this 140, and it's going to be just like the long division. We're going to write plus 140 over our divisor, x minus 3. So that's how we use synthetic division. Some people like it, it's a little faster, but it only works when your divisor is in the form x minus c. So let's scroll down a little bit and look at another example. So we're going to find f of c using synthetic division. And right above here we see something called a remainder theorem. It says, and this is important, if a polynomial f of x, so that's this, is divided by x minus c, then the remainder is r equals f of c. So the remainder is equal to whatever the function equals when you plug c in. So what's happening here is x cubed plus 6x squared minus 9x minus 54 is getting divided by x minus 3. And they're telling us already that c equals 3. So they didn't say x minus 3 this time. They told us that the number we're going to use is 3. So we write 3, and then we write 1x cubed plus 6x squared minus 9x minus 54. So we didn't have any zeros to account for. And we're going to use our synthetic division. Bring down the 1. 3 times 1 is 3. 6 plus 3 is 9. 3 times 9 is 27. Negative 9 plus 27 is 18. 3 times 18 is 54. Negative 54 plus 54 is 0. That's our remainder. And what this remainder theorem said is that if a polynomial is divided by x minus c, then the remainder is always going to be r equals f of c, which is 3 cubed plus 6 times 3 squared minus 9 times 3 minus 54. This comes in real handy if you know that x minus 3 is a factor, you know that c equals 3, and the problem said, hey, just find the remainder. Well, you don't have to do all the division. You can just plug the 3 into the equation and get 27 plus 54 minus 27 minus 54, and you'll see 27 minus 27 and 54 minus 54, so our remainder equals 0. So in this case, it told us to use synthetic division, so we did it, and we came up with x squared plus 9x plus 18, and we got a remainder of 0, so we just proved that this is true. Okay, but for this problem, it said find f of c. Well, f of c is 0 because we plugged 3. C was 3, so we plugged 3 into our equation, and we found f of c. All right, one more. So we have another factor, or another theorem called the factor theorem, and it says that a polynomial has a factor x minus c if and only if f of c equals 0. So on the last one we just did, okay, x minus 3 is a factor of this. If we were trying to factor it, that would be very helpful to find out. This is a factor only because our remainder equals 0. We're going to use the factor theorem to determine if these binomials given are factors of f of x, and then we're going to use the binomials that are factors to write the fully factored form of f of x, okay? So just keep it simple. It says use the factor theorem. Well, the factor theorem says that a polynomial has a factor x minus c if and only if f of c equals 0. So we're determining if this and this are factors. Right, so I notice in your notes you don't have x plus 5 here, and I do. So I'm going to change it to x plus 3, which is what you have. So f of 2 is 3 times 2 cubed minus 2 squared minus 22 times 2 plus 24. And then we're also going to do f of negative 3, which would be 3 times negative 3 cubed minus negative 3 squared minus 22 times negative 3 plus 24. So we'll work both these out and hope that they equal 0. So 2 cubed is 8 times 3 is 24 minus 4 minus 44 plus 24. So 24 and 24 is 48. Minus 4 is 44, so 44 minus 44 equals 0. So that means that x minus 2 is a factor of this. Now we try the negative 3. So negative 3 cubed is negative 27. Negative 27 times 3 is negative 81. Minus negative 3 squared is 9. Negative 22 times negative 3 is positive 66, and plus 24. So now we have 66 plus 24, which is 90, minus 9 is 81. So negative 81 plus 81 equals 0. So we're good. Those are both factors. So now that we've determined that they're both factors, we need to use the binomials that are factors, which is both of them, to write the fully factored form of f of x. And we're going to use synthetic division to do that. So we're going to start with our 2. And we're going to use synthetic division with 3x cubed minus x squared minus 22x plus 24. And we're going to work this out real quick. So bring down the 3. 3 times 2 is 6. Negative 1 plus 6 is 5. 2 times 5 is 10. Negative 22 plus 10 is negative 12. 2 times negative 12 is negative 24. Gives us a remainder of 0, which is what we should expect because we already found out the remainder will be 0 when we divide this thing by 2. Now we're going to come over here and do negative 3. But we're not going to divide it by, we're not going to divide it with our original f of x. We're going to divide it with this new function, new expression that we have. So 3x squared plus 5x minus 12. Okay, bring down the 3. Negative 3 times 3 is negative 9. 5 minus 9 is negative 4. Negative 3 times negative 4 is positive 12. Negative 12 plus 12 is 0. So that's our remainder. But this is still left. So our factors of all of this are x minus 2, which we figured, x plus 3, and 3x minus 4. That's what we have when we divide this 3x squared plus 5x minus 12 by our remaining factor x plus 3. So hopefully that made a little sense. We'll keep practicing it, so don't get too stressed about it. But That's it for synthetic division.